G'day Bifrosters. You know when I start in Houdini we'll be doing a Houdini node, right? Well, tonight we'll be doing the point jitter node. So what a point jitter does is it basically adds a small random amount to the point positions. You have many controls here to control it. We're going to try and get the same functionality as Houdini has into Bifrost. So let's go ahead and get started. We're working with points. Always when I work with points I'm going to want their positions and their normals. So I'm just going to pop this into the output straight away so we can watch this evolve. We need to construct in our minds the functionality of this node. So if we come back over to Houdini, basically like I said, takes the point positions and adds a small random value to them, depending on the scale. You also have other functionality like axis scale. You can scale by axis here. You can get different looks. You can change the seed. Don't worry about the green ones and the sphere in the middle. That was a setup I was running earlier. You can scale by p-scale, and you can update the normals. So we're going to try and get all of this functionality. The group stuff that Houdini has, I'm working on that. I have some ideas and I'll be working on some sort of attribute based grouping or point property based grouping. That is if the wonderful people at Bifrost haven't done it before I get round to it. Really depends on how much work I've got to do in my day job, to be quite honest. So what we're looking for is a small random value we can add to our point positions, and we already know how to do that, especially if you watch the arrays video. I'm going to get my array size, a random value array. Great little node. I believe I've done a video on it. But it will generate an array of random numbers of this many random numbers based on this offset. Now, our positions are vectors. Let's make this a vector. Mathfloat 3. And let's quickly, let's just add that to those positions. Like so. Now, I don't know if you saw that, but it all moved across and up and a little bit backwards. And that's because the random value array will output an array of numbers between 0 and 1 as a vector. So this is adding. We're just adding 0 and 1. We need to find a way to make that both negative and positive. We already know how to do that, but let's real quickly. We're going to need this later. We'll plug the seed into our input so we can now, if we want to, we can change our seed. Everything changes. That's a nice easy one. So the way I'm going to do this is I'm going to do it with a set range node. Set range node is one I've made because it's got my logo on it. You can see that. But I'm just going to set this to -1, -1, -1, 1. There we go. So now we're getting all kinds of random on and more evenly. We're not just going into the positive, we're going positive and negative on both. Great, at this point we have a jitter. It works. You have to come in here to set your values, but we've even got our scale axis working like this already as well, which is pretty good really. So let's go ahead and we'll make ourselves a value node. And this is going to be our main scale value. Let's just name it as such. There it is. Now to get this to be both positive and negative, what I'm going to do is I'm going to take half of it. Half off. Does exactly what it says. And negate. So what this is going to do is take whatever value that we enter into our scale field, let's go for 2, get half of it, which will be 1, and then also negate it, which will be -1. And I can plug this one to my minimum, and this one into my maximum. And then, if I change the scale value, automatically gives us scaling equally in the positive and negative of 3 dimensions. So that's done. That's scale done. Next thing we want to do is the axis scales, like we've got here. So if I want to scale this value, all I really have to do is multiply it by some number. So let's add a value node here. And let's go for 484. It's possibly a little too big, so we'll go for 2, 1, 3. There you go. So this here is literally our axis scales already. So why don't we feed this straight back out? To axis scale. Now if you have a sharp eye, you would have already noticed there was a problem. And that problem is that when this is set to 0, everything collapses into a single point. Yeah, don't want that. Do not like. So we're going to fix this a real easy way. I'm just going to drop an add node in there, create a value node there. I'm just going to add 1 to this. So when our axis scale is set to 0, comes through here, adds 1, passes it on to the scale. So this does our scaling. Like that. So now if I change this to 2, it's actually 3. It's kind of sneaky. You can see 1, 1, 1, and 1 pretty much increases it quite a lot. So now we have our scale, our axis scale, and our seed. What else do we need? We've got the 3 main things here. Use p-scale. Okay, so for this one, a get geo property or default. And this is a really, really handy node that basically says, have a look on this geometry. Point scale. Have a look on this geometry for this property. And if you don't find it, use this value here. So we'll just pop our scale into here. And we only want this to happen if our users ask us for it. So I'm going to pop in an if node. So it immediately sets up a condition. And here we'll just go use point scale. So if it's true, we'll put that in there. And if it's not true, we'll just use the scale we've got set up coming in. We'll feed all of that into our little setup here. If we jump out here and go along a bit, you see I've already set up point scale on these. It's probably a little bit big right now. So we'll take that down. If I turn this on, you can see the scale changes already. And that's because we're now getting the scale from the actual geometry itself. Pop a watch point on here, you can see point scale right there. So that's use point scale done, that's that one done. We've got one more thing to do, which is update normals. And that's going to be just a little more complicated, but not terribly much. So we know we're going to need an if node. Let's pop that in there. We'll call this update point normals. Okay. So the easy way to get normals I've found is if I just take the geometry up here, I'm going to go update mesh normals, and that gives us the point normal, which is really good. So let's just, first things first, set our point position back in our geometry, like that. And I'll go back and find that if node I just made. It's over here. So this is an if node that says, if update point normals is on, do something. So this is going to be pretty simple. So if it's on, we'll take this mesh that has the normals updated. If it's off, we'll take this one, just has the original normals on it, and we'll output that mesh. little output mesh for tidiness. And just because I want to, I'm going to take this guy and I'm going to do the same with the normals. So I'll just disconnect that, I'll disconnect that. So again, this is update point normals. We're going to take our point normal, put it into true. And then for the false, we'll take the normals that we got way back at the beginning and use those. So again, they're still the original normals. We'll pop that up here. Out, point, and normals. And with that done, we are done. That's a working point jitter node. So I can take a look at let's take a look at what it's doing to the mesh. Probably horrible things, because jitters tend to. Yep, that's just torn it apart. However, we turn off use point scale, and then let's just take this scale down. You can see it's nice for giving us little subtle values. Just a little bit of wonkiness. So last thing I'll do before I let you guys go, I'm just going to arrange my interface a little bit. Call it jitter. And yeah, I'll leave my scale there, my axis scale there. Seed I like to drop to the bottom. That's just my personal, so that I can just always change the seed right. I know where it is at all times. But that is very much a working jitter node. It works on points and it works on meshes. And if you want to point mesh, you can do, like I said, you can go out here and construct points like I've done. Use point scale, change the seed. Yeah, it's all doing its thing. So let's go real quickly through it again. So what I did first is I put in the mesh. I got its points and normals. I then took its points and I added a small random value to each point. To provide that random value, I took our scale value from our input, cut it in half, took the negative of that, and then fed that into the minimum maximum of a set range. A set range, by the way, is just an array bounds and a change range. I will take everyone through how I made these personal nodes in another video, but they're pretty simple. They're just, what I tend to do is when I'm not doing projects, I get sick of doing the same thing over and over again, so I make a node and publish it. And then because I have a little bit of vanity, I put my logo on it and I make sure that I've got a little descriptive MD markdown file. So once we've set the range to a negative and a positive value, and that's how we do this. So for example, if we have 2 coming in, and 2 is going to come in, ignore the if for now, it's going to take half of 2, which is 1, and then negate that, which is a negative 1. Negate goes into minimum, half off goes into maximum. The random value array is now spread between, and we can check it out here, -1 and 1. So I hope everybody sees how that works, because it's a handy thing to do. And then we added them back onto our original point positions, which is this line here. Great. We then decided we wanted to do some scaling. So this is a multiply node, and that is coming in from the axis scale. And we worked out that when our axis scale was at 0, and all zeros, when our axis scale was all zeros, it was collapsing everything down into a point. So what we did is we just added 1 to it. So when the axis scale is 0, nothing changes. It will always be this scale that you put in here, or that you derive from your point scale. Any changes you make to that axis scale, if we set that to 1.5, that's actually a 2.5 scale. We got that working, and that was happy. That went out to the point position and out to the output. Next thing we did was use point scale, where we talked about the get geo point scale or float, which will get a property from this geometry, and if it's not there, it'll just output this value. And for this value, we plugged in our scale. That was great too. We set up the condition for that. So this attaches quite literally to here, and if this is true, it looks for a point scale, passes it through. If it's false, it doesn't even look and just goes straight off the scale. Then we did our update point normals, which we did by bringing our mesh through, setting the new point positions, then updating the mesh normals. We used 2 if statements on the same condition to say, if do you want updated normals? Well, if you do, these are the updated normals, out they go, and these are the outdated normals, and up they go. If you don't, these are the original normals as normals, and this is the original mesh with normals on it. And that, Bifrosters, is the Jitter node. Moving on from here, I'll probably do more videos, of course. Very soon now I'm going to be starting to tie some of these videos together into something a little more complicated that we can all get our teeth into, including me, so you can watch me make mistakes as I go. Alright, I hope this has helped, and I'll see you next time. Thanks a lot.